This is question 9, paper 1, from the SQA Specimen Paper for National 5 Mathematics. We're told that a parabola has this equation, and we have to write the equation in this special form. So x squared minus 8x plus 19, and we have to write this as an expression squared plus some number. Now this is called completing the square. Let's take a squared expression, for instance, like x minus 1 squared, and let's just explore the answers to expressions like this when you multiply them out. So first outsides, insides last. The first two terms multiplied give us x squared. Outside 2 negative x, inside 2 negative x, so that's negative 2x. And the last two terms multiplied, negative 1 times negative 1 gives us plus 1. Let's do one more, x minus 2 squared. X minus 2 times x minus 2. So that'll be x squared. And there's a minus 2x from the outside two terms and a minus 2x from the inside two terms. That's minus 4x, double the 2. In this first case, we had minus 1x minus another 1x. That was double the minus 1, so you get a minus 2x. And the last two terms multiplied give us positive 4. But the crucial thing to notice is that this minus 4x is double the minus 2. And this minus 2x is double the minus 1. So here we have a minus 8x. So surely we should be looking at double a minus 4. So let's try and work out minus 4 all squared just to see how close we are to getting our answer. So firsts give us x squared, outside 2 minus 4x, inside 2 give us another minus 4x, that's minus 8x as we wanted, and the last give us negative 4 times negative 4 is plus 16. So our x squared is taken care of, the minus 8x is taken care of, the plus 19 is not taken care of. We only have a plus 16 when we square that out. We're 3 short. Well, let's just add that on. And there's our expression, x minus 4 all squared plus 3. So let's move on now to the second part of the question. Sketch the graph of this parabola, showing the coordinates of the turning point and the point of intersection. Well, here's our x-axis and our y-axis. Now, the interesting thing about x minus 4 squared plus 3 is that we are squaring something and then adding 3. And the smallest value something squared ever gets is a 0. So the smallest value this ever gets is 0 plus 3. So the smallest value is 3. And we know that we have a parabola with a positive x squared term. Therefore, the graph is going to be shaped like this. This is concave upwards. The other alternative is a concave downward graph. This only occurs if the x squared term is negative. So we know we're in this concave upward graph. We have 0 plus 3 as our minimum. That occurs when this expression here, x minus 4, is 0. That'll happen when x equals 4. 4 minus 4 gives you 0. So when x is 4, we get 0 squared plus 3. And that's the smallest value you get for this expression. So if we go 4 along and 3 up, there's the concave upward parabola with minimum value 4, 3. Now it remains to find out where on earth it crosses the y-axis. to do that, we'll set x equals 0. So if we go back to our original graph formula and put x equals 0 in here, this will be 0, this will be 0, and we'll end up with 19. So it crosses the y-axis at 19, or 0, 19. Let's just put that in because it does ask for the coordinates of the point, the coordinates of the turning point and the point of intersection of the y-axis. So 0, 19 for the point of intersection of the y-axis and 4, 3 for the turning point, minimum turning point. And one thing to be emphasizing here is that if you're asked for the minimum value, in this case the minimum value would be 3. That's your y coordinate. The minimum value of this, smallest it ever gets, is 3, and the minimum turning point is 4, 3. So if you're asked for a minimum value, you state the y coordinate 3. If you're asked for the minimum turning point, you give the coordinates 4, 3. Now there is another way of getting this sketch, and I think we should have a look at that. So here's the graph of y equals x squared. 1 squared is 1, 2 squared is 4, minus 1 times minus 1, minus 1 squared is 1, negative 2 times negative 2 is 4. So this parabola, y equals x squared, and what we can do with this is move it to the left or right. There it is being moved to the right. In that particular position, we've got the graph of y equals x minus 3 squared. So that's x minus 3 all squared, and it moves 3 units to the right. If we move it the opposite direction, we'd be in this position, for instance, we'd be looking at the graph of y equals x plus 3 all squared. So when there's a plus number there, you're moving it to the left of the origin, and there's a minus number there, you're moving it to the right of the origin. Let's look now at moving it up parallel to the y-axis. In this position, we've got y equals x squared plus 2. We've moved it 2 units up parallel to the y-axis, and going the opposite direction, we can subtract 2. So the graph in that position would be y equals x squared minus 2. And we can certainly combine these two left-right movements and up-down movements. For instance, let's have a look at this position. Can you guess what the formula for that graph is? Well, it's y equals x minus 2 all squared, because it moved 2 units to the right parallel to the x-axis, and it's moved 1 unit up, so it's a plus 1. Let's try another one. What about this position? Can you work out what the graph formula is in this case? Well, this is y equals x plus 3, because it's moved 3 units to the left parallel to the x-axis, and it's moved 2 units up, so there'll be a plus 2. So it's y equals x plus 3x squared plus 2. So the particular example from the question involved x minus 4 plus 3. So there's the position, and the graph that we were looking at in this question had formula y equals x minus 4 all squared plus 3. So it had a minimum turning point with coordinates 4, 3. It has a minimum value of 3, but the minimum turning point is 4, 3. Now we can just check that it does cross the y-axis at 19. I have to drag this down a bit to see it, and there you have it. The y-intercept is 0, 19.